In this topic, you will learn about flocculation, their characteristics, and the different types of flocculants available. You will also be able to identify the advantages and disadvantages of the flocculants. This will enable you to recommend the right flocculants to your customers, along with the reasons for your recommendation. After completing this topic, you will be able to match the various types of flocculants with their descriptions. Let's look at how beer is made to understand the process of flocculation. To make beer, yeast is added to the malt. Initially, the yeast particles are uniformly dispersed and suspended in the solution. Towards the end of the fermentation process, when the nutrients have been used up, the chemistry changes. The yeast then starts gathering together to form larger lumps and settles to the bottom of the fermentation vessel. This process of the yeast particles coming together to form larger lumps is called flocculation. Flocculation is a method to chemically increase the size of the coagulated particles so that impurities in wastewater settle out. During flocculation, the physical interparticle bridging mechanism relies mainly on the size and structure of the flocculant molecule rather than on its charge density. High molecular weight polymers work primarily through interparticle bridging. Polymers of long chain and branch structure increase the efficiency of the flocculation. Selecting the right flocculant is greatly influenced by four characteristics: molecular structure, charge, molecular weight, and form. With the advancement of technologies, the manufacturing of polymers that have precise placement of charges are possible. The optimum spacing between the charges ensures that all charge sites are used and that expensive charge is not wasted. Different molecular structures have its use for a range of unique applications. Polymers might have different charges, either positive as in cationic polymers, or negative as in anionic polymers, and non-ionic polymers. The charge density of different polymer molecules may be different. For contaminant particles that have a low charge, you need flocculants of low charge density and vice versa. Molecular weight affects the selection of the flocculant. Flocculants have different molecular weights ranging from low, medium to high. Low molecular weight flocculants vary from 1,000 to 20,000. Medium molecular weight flocculants vary from 20,000 to 500,000. And high molecular weights are 500,000 and above. Molecular weight indicates the size of the polymeric molecule. A large molecule tends to do a better job in interparticles bridging mechanism. Polymers are available in four different forms: powders, liquids, emulsions, and dispersions. The powder forms are highly concentrated at 90 to 100%. The liquid polymer forms are low concentrated at 1 to 10%. Emulsion polymers, which are composed of water, polymer, and oil, have concentration levels of between 25 to 50%. Brine dispersions are cationic flocculant liquids that have a concentration level of 15 to 25%. Powders and emulsions have high molecular weights. Powder is the most concentrated form of flocculant. It is the most expensive on a unit price basis, but it is the least expensive to use. However, it is difficult to feed. It requires a special makedown or chemical mixing system. It is available as a high molecular weight cationic, anionic, and non-ionic polymer. Liquids cost more than powders, but are easy to handle. You may need to dilute it to feed it in. In many cases, it can be fed neat without dilution. It is usually available as a cationic low molecular weight material with high charge density. Emulsion is another type of flocculant that has a higher concentration than the liquid form. The polymeric molecules are encased in fine water droplets, that are in turn emulsified in a continuous oil phase. Before a molecule can serve its purpose, it needs to be activated from the water droplets to open up the molecular structure. To activate a molecule, it requires an inversion process and needs a special makedown or chemical mixing system. It is available as a cationic, anionic, and non-ionic high molecular weight polymer. Brine-based dispersions are available as cationic flocculants. The makedown for this form of flocculant is fast and easy. It only needs to be diluted with water. However, dispersion need to be mixed periodically in bulk storage to prevent separation and gelling of the product. This completes the topic of flocculants. Here is the summary of the key points. We now have reached the end of Flocculants topic in the wastewater treatment series. Thank you for listening and watching this lecture. If you would like to see other courses, please visit watertreatment.training.